In this video, I'm going to be talking about voltage, currents, and resistance. So let me start by explaining what voltage is. So voltage is the difference in electrical potential between 2 points. So it's the forces that pushes electric charge through a circuit. Let me use an analogy of water flowing through a pipe. So let's say you have a pipe and you have water flowing through it. Voltage is the pressure that is pushing the water through the pipe. So we can say voltage is the pressure that pushes electricity through the wires. So the greater the pressure of the water through the pipe, the greater the voltage. So we can say the greater the pressure in the wire, the greater the voltage. And voltage is measured in volts. It can also be expressed in millivolts, kilovolts. So 1 millivolt is 10 raised power minus 3 volts, and 1 kilovolt is 10 raised power 3 volts. So let's explain what electric current is. Electric current is the flow of electric charge through a conductor. So I'm going to be using the same analogy I used when explaining voltage. So we have a pipe and we have water flowing through the pipe. So electric current is the amount of water flowing through the pipe. That is the amount of charges flowing through the pipe. So if the water is flowing slowly, that is the charge, you have a small current. And if a large amount of charges are flowing through the wire, then you have a large current. Current is measured in amperes and can also be expressed in amperes. So milliampere is 10 raised power minus 3 amps. There are some simple rules to know when dealing with voltage and current, especially in a circuit. So first is, I'm going to use a battery to explain it. So let's say you have a 1.5 volts battery. It's positive and negative. This is a 1.5 volts. And the current of the battery is 0.5 ampere. If you connect this battery in parallel, in parallel, so when you are connecting in parallel, the positive will connect to positive, then the negative will connect to negative. Then you have your outputs. This is positive and this is negative. So when you have this kind of connection, parallel connection, your voltage will remain the same. So the voltage of this connection will be 1.5 volts. But because it's parallel connection, your current is going to increase. So your total current of these outputs will be the sum of all the current of the battery. That will be 0.5 plus 0.5 plus 0.5. So that will give us a total of 1.5 ampere. So this will be the total current gotten from this connection and total voltage. Now let's look at when we connect it in series. So when you're connecting in series, negative goes to positive, negative goes to positive, then you get your output from here, positive and negative. So when you're connecting in series, the voltage is going to increase. So the voltage from this output will be the sum of all these voltages. So that will be 1.5 in added all together. That will give us 4.5 volts. And since we are connecting in series, your current will remain the same. So the current will be 0.5 amperes. So let me go over it again. When you're connecting in parallel, your voltage remains the same, your current increases. And when you're connecting in series, your voltage increases and your current stays the same. Now let's talk about resistance. So resistance is the ability to resist the flow of electric current, and is represented by a symbol R. And resistance is the physical property of a resistor. The resistance of any material within a uniform cross-sectional area depends on the cross-sectional area and its length, and also the resistivity of the material. From this, we can get the formula that your R will be equals to the resistivity of the material multiplied by the length over your cross-sectional area. So we can use this formula to judge, based on the physical property of the conductor, if the resistance of the wire will be greater or lesser. So let's look, for example, let's look at a long wire with a greater length and a wire with a very short length. So from the formula, we can see that the greater the length, the greater the resistance. So a longer wire, we have greater resistance. We have more resistance than the shorter wire. And if you have a thin wire and we have a thick wire, so which of these wire we have greater resistance? So from the formula, we can see your A. The smaller your A, that's your cross-sectional area. The smaller your cross-sectional area, the greater your resistance. So a smaller wire, we have a greater resistance. If you have any question, please leave a comment.